Today we are learning how to construct linear functions. Your learning target is I can write linear functions from graphs, tables, and verbal descriptions by finding the rate of change and the initial value. So, what is it? A linear function is a function that is an equation in the form of y equals mx or y equals mx plus b. The graph of a linear function forms a straight line. Imagine that, because linear means line. The slope, which is m, of a linear function is also known as the rate of change. Hey, remember when we talked about the change in y divided by the change in x? Yep, that's what we're talking about again. The rate of change between any 2 points in a linear relationship is going to be the same or constant. The y-intercept, b, of a linear function is also known as the initial value. The initial value is the corresponding y value when x equals 0. All right, so today we've got to find these equations. In example 1, we need to construct functions from graphs. A shoe store offers free points when you sign up for their rewards card. Then, for each pair of shoes purchased, you earn an additional number of points. The graph shows the total points earned for several pairs of shoes. Find and interpret the rate of change and initial value. Then, write an equation of the function in the form y equals mx plus b. How are we going to do this? Well, we got to find our rise, which is this guy right here on our graph, over our run, which is this way on our x-axis. I see that our rise goes up 30 and our run goes over 2. Make sure you're looking at the individual segments there. So look at rise over run, which is our slope. We get a change in y, which is 30 divided by 2 gives me 15. All right, so I can plug this into an equation, lickety-split, and I get 15x plus b. But I don't want to write just b, so I'm going to look for where my x value is 0, and I see that there is a point at 0, 30 on my graph. So my new equation is y equals 15x plus 30. Example 2. The table shows how much money Ava has saved. Assume the relationship between the two quantities is linear. Find and interpret the rate of change in the initial value. Then write the equation of the function in the form y equals mx plus b. So we're looking for our slope, first of all, which is our change in y divided by our change in x. I'm going to look at the change in y in my table first. That's just where I like to start. It doesn't matter. I could go to my x values too. And I'm seeing that there's a difference between the two of a positive 20. So on the x side, which is our months, I'm seeing that it goes up constantly by 1. So what this means is that our rise over our run, our change in our x value and our y value, the change in the y value is 20, and that goes over 1. Or we could just say our slope is 20. All right, let's put it into an equation now. Now I'm going to write it out as y equals, we know our slope is 20, x plus b. So we are still missing some of our information. We need to keep going with this thought process. Now that we have the slope, how do we find the y-intercept? And what is the y-intercept? Okay, so the y-intercept is when x equals 0. Well, how am I going to figure that out? So one of the ways in which we can find our y-intercept is to take the values from our table or an ordered pair from our table and plug them into the equation. So I have chosen the first set of coordinate pairs. Our x value would be 3. Our y value would be 110. So plugging in 110 for our y And then I keep our slope at 20, multiply by 3, and add b. I am looking for the y-intercept, so our b value is what I need to solve for. How am I going to do that? First, I need to use the distributive property and solve for 20 times 3. I get 60 plus b on that side, and 110 stays the same. All right, now it's just a matter of removing 60 from both sides to see that our b value, our y-intercept, is going to be 50. Now that we know our y-intercept is 50, we can write an equation in the form of y equals mx plus b. We would just simply replace that y and say y equals 20x plus, you guessed it, 50. Example 3, Joan plans to add 12 photos to her photo album each week. After 8 weeks, there are 120 photos in the album. Assume the relationship is linear. Find and interpret the rate of change and the initial value, then write the equation of the function in the form of y equals mx plus b, where x represents the number of weeks, y represents the total number of photos in the album. So what's really important up here is to note that she adds 12 photos every single week. That's our slope. And after 8 weeks, there are 120 photos. So we need to write an equation in the form of y equals mx plus b. Since we know she adds a constant rate of 12 photos each week, our rate of change, our slope, is 12. So we are going to rewrite this as y equals 12x plus b. But in order to rewrite it, I need to find my b value. So I'm going to take that 8 weeks and the 120 photos. X is going to be your weeks. So we say 12x plus b. All right, I'm going to plug this guy in over here for x. I'm going to have my 120 in for y. And I'm going to rewrite the equation. 120 equals 12 times 8 plus b. Now it's just a matter of solving for our b value. We have an equation. We need to multiply that 12 times 8 to get 96. We get 120 equals 96 plus b. All we have to do now is subtract 96 from both sides, and we will have our y-intercept. So that y-intercept is the b value, and that's when x equals 0. So if we start at 0, what is our number of photos that we're starting with is what we're trying to figure out. So when x is 0, we have 24 photos in that photo album. So now we get the equation of y equals 12x plus 24. And that's going to be our final answer. If you have any questions, please be sure to ask me later.